So this is 21. 21 asks us, it's the opposite of what we just got done doing, but 21 says x equals sine of t, y equals cosine of t, and then t is from, or cosine of 2t, and then t is from negative infinity to positive infinity. So what we want to do is we want to graph that first and take a look at it. So x is equal to sine of t, and then y is equal to cosine of 2t. Alright, and then I'm going to come in and click on window, and I'm going to put like my minimum is negative 10 and my max for t is positive 10, because I can't plug in negative infinity or positive infinity, so I just pick some numbers. And then I'll hit graph. And oh man, that draws like a goofy little line, doesn't it? So maybe we'll put in some bigger numbers than that. Okay. So what do we want to do? So the textbook, we just need to find the Cartesian coordinates. So I'm going to zoom in on this. Maybe I'm going to change that a little bit. Maybe I'll do like negative 20 to positive 20 to see what the graph looks like and see if it changes it much. And I see that this thing is just going bonkers here, right? So maybe it's like drawing a lot, okay? Maybe it's drawing something a lot. So I'm going to zoom in, because so let's do this one more time. I'm going to do like negative 50 to positive 50. And so maybe there's a cycle. Maybe this repeats or something. I don't know. So I'm going to hit graph again. And so now it looks like it's just going over the same graph, over the same graph, over the same graph, over the same graph. My calculator is literally plotting all these points. Okay? So now what we need to do then is, if that's the case, I need to convert that somehow, some way to some sort of equation. It kind of looks like a parabola upside down, right? It kind of looks like a parabola upside down. So let's zoom in and see what it looks like. So if I hit zoom fit, it looks like a parabola, doesn't it?
Yes. This is what mine looks like.
Well, it depends on how many steps you have. Mr. Adams has really small steps. If your steps are too big, you'll get some funny pattern. But because I've zoomed in, so really that's like it. It looks like a parabola, but it looks like it has some sort of boundary, right? So if I zoom out just a little bit, if I go to like, let's set the window from my X-min, I'm going to set that to -4. My X-max I'll set to +4. And then for my Y-min, I'm going to put -4. And my Y-max is +4. And we know that the pattern tends to repeat itself, so I'm just going to do like -10 to +10 for T. And my step is a real small step, okay? So now I'm just going to graph this and see what it looks like. And so now it looks like a portion of upside down parabola with a y-intercept of +1, I think, right? So if I hit trace and I come around here, as t changes, it looks like my y value gets close to 1. And then, so how do I write the parabola? How do I do that? Well, you'd have to know some trig identities. Okay, so what is the double angle for sine and cosine? Does anybody know that?
I don't know how to say it. It's like SCC and COT. No, not COT. COT is cotangent.
Well, let's look it up. Okay, so if we look up trig double angle formulas, And I'm just picking out some random website. Now the reason I'm doing this is, let me show you what we're doing here. If we look at the problem, see, I have x is equal to sine of t and y is equal to cosine of 2t. So now what I need to do is I need to take this y equals cosine of 2t and somehow convert it into something of sine or something, because I need to be able to plug y equals something t or something like that, okay? So I suspect the way that I do that is the double angle formula. So what I'm looking for is cosine of 2a. So let me write that down too. We say that cosine of 2a is equal to, and if I were to guess, I would probably go with that last one, which is 1 minus 2 sine squared of a. Why did I go with that last one?
That's when I solved it.
Well, because if I look at my parametric equation, x is written as sine of t. Okay? So now let's translate this a little bit. So if y is equal to cosine of 2t, by this formula, cosine of 2t is the same as 1 minus 2 times sine squared of t. Right?
Yes.
Now, how do I plug in my x? In other words, what I've done is I've written this as y is equal to 1 minus 2 sine squared of t. What is that in terms of x?
It's negative 2x squared plus 1.
Yeah, it's so it's 1 minus 2x squared, right? So my Cartesian equation is equal to 1 minus 2x squared. Or we could, the way she said it, we would say it's negative 2x squared plus 1. And that is the graph that we had, right? So that one's a little trickier. What are you noticing about these parametric equations, though? To write the parametric equation into a Cartesian equation, it's very simple. You've got to find an easy way to plug your x into the y. This is really systems of equations. This was a hard example because you have to know the trig identities, right? Now, Mr. Adams knows what they are. Why did I go through and look it up on the internet? To show you that you could look them up on the internet. Although right now everybody's supposed to be in courtesy mode.